Let's start this video with this example. You deposit $200 now in account earning 3%. When it doesn't say anything, just consider it annually. After 5 years, the value in account is one of these options. So you see, now it expects more attention from you to the details. As you can see, there are negative and positive answers over there. So stop the video and do the example. Okay, I'm going to show you the answer, but since it is deposit, it is negative, so the return in 5 years would be a positive. So D is now crossed off. And here is the answer. So since it is the future value, FV 3% for the rate 5 years or 5 periods, there is no payments, and the present value is the deposit of 200. And deposit of 200, that's the reason here you see I have put minus 200. And the result is 231. So it is the answer. Example 4.3. How much must Jim deposit at the end of each month to get $1,000 at year end? Bank pays 6% interest, compounded monthly. So I suggest when you want to do any this type of problem, draw the cash flow diagram. It always helps. How much must Jim deposit at the end of each month? Let's first not spoil this challenge for you. So I'm asking you to stop the video and try to do it yourself. And my first suggestion was that draw the cash flow diagram for this challenge, and it will help you to handle it in an easier way. I'm going to do the cash flow diagram here. Here we have 12, month 12, and what he wants to get, so it would be upward. $1,000 at this time. And now the question is about a deposit. Is it one-time deposit? No, it happens at the end of each month. So in our terminology, it is called payments. How many of them? We have 12 of them. So one, two. So here you see the timeline, and we are gonna have 12 payments. So it goes all the way down until here. And it is asking you about these payments, how much you need to pay to get that. Now you have this help if you were wondering about the diagram. So again, stop the video and try to do the rest of that. I told you, be greedy regarding handling the challenges yourself. It always adds to your skill. Another point that we have is this 6% interest compounded monthly. When it says it's compounded monthly, it means that it is the nominal annual return. So the interest rate here would be 0.5% per month. So the next step is just inputting this data and get what is the payment should be. What should be the payment? What the payment should be. Here you can see the answer. Since we are after payments, the formula we put here is equal PMT, payment. And let's have the help from Excel. The rate is 0.5%. The number of period 12. We don't have any PV here. Once payment at the beginning of the period, at the beginning of the investment timeline, or at the beginning of that present value, the initial value that we had, the initial investment cost or anything that we have at the beginning of the cash flow. But we have here FV. And when I click on 1000, you see it gets bold. So 1000. And the result would be you have to pay $81.07 per month. So with this rate of return, with this interest rate, at the end of the year, you would have $1,000. It's so help to feel in control, that from now on you understand that all these numbers that you see have this simple logic behind them. Even now, when you are being asked about the future value, you can specify the amount of payments. Here also you have it documented here. And as of now, don't bother yourself about this formulation. It is just formulation. It is not about that concept. That is my first focus and priority in this course. Example 4.4. So let's do it. I told you, you will be bombarded with many examples in a way that if you work hard, you will master all these concepts. Okay, a machine costs, when it is cost, it means that it is downward arrow. A machine costs $5,000 and lasts 5 years. How much we are familiar with this terminology. This car will work for you for 8 years more. Does it worth it? Is it worth it? I changed the transmission, for example, for a hefty amount of $12,000, just the transmission. You can now do all this math on a piece of paper. If interest is 8%, so when it doesn't provide you any more information, it means that it is annually. How much must be saved annually to recover the investment? And we have talked about this when it's talking about how much must be saved. It means that this machine, how much gonna contribute to your life, business, personal, or anything. That's the special way we have in wording field of finance. So stop the video and expect from yourself to do it on your own. Now go and check the video, go and check the other examples. You should be able to do this on your own from scratch. go with the cash flow diagram, all the calculation, and get the results. And when you see the results you got are the same as what I will show you shortly, feel proud of yourself. Here you see the formula we need to use for this case. It is calculating the payment because it is asking you for recovery during 5 years. So since it is recovery during 5 years, it is recurring type of things. It is recurring type of income. So payment, the interest rate 8%, NPR 5, and the amount of money you invested at the beginning is 5,000. So we are going to see how much this car, this machine, should save for us for the following 5 years to make it worth investment. Okay, the car should save you $1,252.28 per year, so it is worth it. What if it is giving me $1,100 saving per year? No, it is not worth it. Forget about that. You are going to lose money. But it is making me $1,100 saving. Okay, that's correct. $1,100 saving it makes for you. But remember, you are also paying $5,000 for it. But this is the point, the equivalent point with 8% rate of return. It seems equivalent. If not, forget about that. Just go and put your $5,000 somewhere else, and with that competitive 8% interest rate, you are going to make more money. You are going to save more. Here we have everything you need. 5,000 at the beginning, 0 time, downward arrow, 5 payments. And here is the formula that I just showed you. Just here it is in different structure. And of course, this structure is better than what I showed you, because in that situation, you make your model dynamic. And you can check PMT for different values of interest that you can put here. And you can create sophisticated structures that can make any supervisor surprised and wowed. Quick example, to have $1 million after 40 years. Now another point that this example wants to tell you is when you go for big numbers, when you go for strategic planning, where you go for long-term decision making. To have $1 million after 40 years in account earning 6%. How much you need to put? Your annual deposit must be any of these things. So now we are sure it is deposit, downward. And let's check what we get. Of course, now you know. Stop the video, do it yourself, and just get the answer. And compare the answer with what you see shortly. Here is the answer, 6%, 40 years, and 1 million. And so the answer would be $6,462. Here is the answer that we have. And so if someone asks you, oh, you just graduated from business school, I want to have $1 million in my account after 40 years when I retired. with 6%, how much I need to put every month? You are going to tell them $6,462.